Have you ever wondered why mining trucks are so big? We're talking about vehicles that look like steel monsters, gigantic machines that make an ordinary semi-truck look like a toy. In this video, you'll discover the reasons behind the absurd size of these trucks, understand how they work, where they're used, and why they are indispensable for modern mining. But before we continue, don't forget to like the video and subscribe to the channel, because here you'll always find amazing curiosities about machines, technology, and engineering that move the world. Imagine a two-story building, more than 8 meters tall. Now put wheels the size of an entire room and a weight that can exceed 800 tons. That's the size of one of the largest mining trucks on the planet. These vehicles weren't made for regular roads. They can't drive on highways or avenues. They exist for a single purpose: to transport gigantic amounts of ore in open pit mines. To understand why they're so big, we first need to understand how the mining process works. In a mine, tons and tons of earth and rock must be removed every day to extract minerals like iron, copper, coal, gold, and other elements that are part of our daily lives, even if you don't notice. The steel in the car you drive, the copper that brings electricity to your home, the coal that powers power plants, all of this depends on these colossal trucks that carry ore from the excavation fronts to the processing plants. The gigantic size isn't just about visual impact. There's an economic and operational logic behind it. In mining, time is money, and fuel is money too. Imagine if a mine had to use regular trucks, each carrying 30 tons. It would take dozens of trips to move the same load that one mining truck can carry in a single run. That's why they're designed to haul 300, 400, or even 450 tons at once. The bigger the load, the lower the cost per ton transported, and the greater the efficiency of the process. Another key point is the geography and the environment where these trucks operate. We're not talking about smooth asphalt highways. They work in real hellscapes of mud, dust, potholes, and steep inclines. The terrain in an open pit mine changes all the time. One day it's dry and dusty. The next it might be covered in mud or even snow, depending on the region. To handle these conditions, the trucks need gigantic wheels, insanely powerful engines, and a structure capable of withstanding impacts and weights that would destroy any other vehicle. And if you think driving one of these monsters is easy, you're wrong. The driver doesn't sit in just any seat. He's practically at the top of a building, looking down at the world. Just the ladder to climb into the cab is taller than an adult person. These trucks have advanced steering and monitoring systems because maneuvering 400 tons of ore in a tight space requires skill and technology. The history of these giants is also fascinating. Since the 1960s, mining companies realized that ordinary trucks couldn't handle the job. That's when manufacturers like Caterpillar, Komatsu, Liebherr, Bel Azid, and Hitachi started designing increasingly larger models, focused on carrying massive loads. Today, for example, the Bel Azid 75710, built in Belarus, is considered the largest truck in the world. It can haul an impressive 450 tons in a single trip. To give you an idea, that's the weight of 300 passenger cars combined. But it's not just brute force. Many of these modern trucks use cutting-edge technology. Some are hybrids, combining diesel engines with electric systems to save fuel and reduce emissions. Others are being tested as fully electric, paving the way for a more sustainable future in mining. It's impossible not to be impressed when you see these giants in action. The tires alone can cost tens of thousands of dollars each, and a full set easily exceeds the price of a house. The engine, in turn, is so powerful that it's often compared to jet turbines, reaching more than 3,000 horsepower. And the question remains, why are they so big? The simple answer is efficiency, but the complete answer involves a mix of economics, technology, engineering, and necessity. They need to be huge because the modern world depends on an absurd amount of minerals. And only machines of this size can extract and transport all that in time and at an acceptable cost. When we talk about mining trucks, the list of giants is almost like a gallery of legendary monsters. Let's start with the most famous of them all, the Caterpillar 797F. Built in the United States, this truck is considered a symbol of modern mining. It can carry up to 400 tons of ore in a single trip, and its engine produces more than 4,000 horsepower. To put that in perspective, that's nearly 10 times the power of a luxury sports car. The 797F is mainly used in mines in Canada, Australia, and South America, where large-scale iron, copper, and coal mining demands industrial-scale transport. But if the 797F is impressive, The title of the world's largest belongs to the Belaze 75710 from Belarus. This truck is simply colossal, 20 meters long, 8 meters tall, and capable of hauling 450 tons at once. To give you an idea, it's so big it had to be built in parts and assembled at the mining site. The Belaze 75710 is mainly used in coal mines in Siberia, where conditions are extreme, with temperatures dropping below minus 40 degrees Celsius. And even in that freezing cold, it keeps running because it was designed to withstand situations that would destroy any ordinary truck. Another giant worth mentioning is the Komatsu 980E4, made in Japan. Unlike the Caterpillar, which has a purely diesel engine, Komatsu uses a hybrid system, combining diesel power with electric drive. This improves efficiency and reduces fuel consumption, something essential in operations that spend millions of liters of diesel per year. The 980E4 also carries 400 tons and is famous for its reliability. Many mines prefer the Komatsu precisely because it requires less maintenance compared to other models. And we can't forget the Liebherr T284 made in Germany. The Germans are known for their precision engineering, and this truck is a perfect example. With a capacity of up to 400 tons, the T284 is considered one of the most efficient trucks in the world, striking an excellent balance between weight and payload. It's so advanced that it can be customized to meet the specific needs of each mine, from engine type to electronic control systems. Last but not least, we have the Hitachi EH5000 AC3 from Japan. This truck also uses electric drive and is famous for being one of the quietest in its category. In mines where dozens of trucks operate simultaneously, reducing noise means greater safety and less stress for operators. In addition, the EH5000 AC3 is widely used in copper mines, especially in Latin America. These trucks are true colossi, but we can't forget that each one costs tens of millions of dollars. And it's not just the purchase price. Maintenance is extremely expensive. Just the tires for a truck like the Caterpillar 797F can cost up to $40,000 each, and a complete set easily exceeds $300,000. And these tires need frequent replacement because the weight and harsh mine conditions wear down the rubber quickly. Another interesting detail is that these trucks aren't delivered ready to use, like a regular car. They're shipped in massive parts and only assembled directly at the mine because there's no road in the world capable of transporting a truck of that size in one piece. It's like a giant build-it-yourself kit, but each piece weighs tons and requires enormous cranes to be put into place. And you might be wondering, what's it like to drive one of these trucks? Well, for starters, the cab is nearly 10 meters off the ground. The driver climbs enormous stairs, and once inside the cab, the view is more like that of an airplane. The controls are similar to a normal truck, but everything is scaled up. The mirrors are huge, cameras are placed all around the vehicle, and computer systems help the driver maneuver. And that's essential, because maneuvering a 20-meter-long truck, loaded with hundreds of tons in an area full of other vehicles and machines, is a task that demands total concentration. The drivers even receive specific training. It's not enough to have a truck driver's license. You have to train on simulators that replicate mine conditions exactly. The simulators are like super realistic video games, with cabs identical to the trucks, able to prepare drivers for situations like brake failure, skidding in mud, or steep downhill slopes. Only after hours and hours of training is an operator ready to take control of one of these giants in the real world. But why not use trains or conveyor belts instead of such expensive and complex trucks? The answer lies in flexibility. Trucks can go anywhere in the mine, follow the excavation front, and change routes as needed. Trains and conveyors are fixed, cost a fortune to install, and don't have the same versatility. That's why, even costing millions, trucks remain the best solution in many operations. And there's more, these vehicles don't operate alone. Each truck depends on a complex piece of electronic equipment we use today depends on minerals extracted in operations like these, and each one of these giant trucks is a key piece to make it all work. The work cycle is roughly like this. An excavator or loader fills the truck bed with hundreds of tons of ore. The truck then travels to the crushing area, where the rocks are broken down into smaller pieces. From there, the ore goes through other steps until it becomes the final product, ready to be exported or used in local industries. It sounds simple, but every trip these trucks make requires planning. They must keep a constant flow, almost like a giant anthill working in perfect sync. And that's where size comes in. The bigger the truck, the more ore it can carry per trip. That reduces the number of journeys, saves fuel, decreases wear and tear, and ultimately makes the operation cheaper and more efficient. It's the same logic as buying something in bulk. It's more cost-effective. Only here, we're talking about hundreds of tons of rock, not bags of rice or beans. But driving one of these colossi on a mining road is no job for just anyone. The tracks are uneven, full of dust, mud, and potholes. A poorly executed turn can make a 400-ton truck tip over, and recovering it is no easy task. Descents are especially dangerous. Imagine a loaded truck going down a steep slope with hundreds of tons pushing it forward. The braking system must be extremely reliable, and the driver must keep his cool to stay in control. There are reports of drivers who, at first, are afraid just to step into the cab. After all, the height is massive. The ladder to climb up feels like a climb on its own. Once they're up there, the world below looks miniature. Normal cars look like toys, people look like ants. It's an experience that mixes fascination with respect, because any mistake can be catastrophic. To avoid accidents, many mines have already adopted cutting-edge technology. 360-degree cameras, proximity sensors, radars, and even automatic braking systems help drivers. In some places, like Australia, there are already entire fleets of autonomous trucks that drive themselves without a driver. They follow pre-programmed routes, communicate with each other, and work day and night without rest. That's the future of mining, and little by little, it's spreading to other parts of the world. But even with all this technology, there are still huge challenges. One of them is the climate. In Siberia, for example, temperatures can drop to minus 50 degrees Celsius. In that cold, fuel can freeze, tires become rigid, and the risk of breakdown skyrockets. In desert regions like Australia, the problem is the opposite. Extreme heat, sometimes exceeding 50 degrees Celsius during the day. That affects the engine, the cooling system, and even driver comfort. Another challenge is the cost of operation. Each truck consumes thousands of liters of diesel per day. Keeping dozens or even hundreds of them running is astronomically expensive. That's why mining companies are constantly looking for ways to save fuel, whether with more efficient engines, partial electrification, or full electrification. Some companies are already testing giant electric trucks powered by batteries or even hydrogen. If that technology takes off, it could revolutionize the industry. And of course, we can't forget the risks. Working in a mine is a dangerous profession. In addition to the risk of rollovers and accidents with trucks, there's the danger of landslides, controlled explosions that must be carried out safely, and even health issues due to constant dust exposure. Drivers spend hours inside the cab, exposed to intense vibrations and machine noise. That's why many companies provide constant training, safety equipment, and frequent medical checkups. Even so, there's also a sense of pride. For those who work with these giants, there's a feeling of power and responsibility. Not everyone can say they've driven a truck the size of a house, hauling more than 400 tons of ore. Many drivers compare the experience to flying a plane, but on the ground. And that comparison makes sense, since the level of training and attention required is almost the same. What's most curious is that even though they are massive and seemingly indestructible, these trucks require daily care. There's an entire team of mechanics, engineers, and technicians dedicated solely to their maintenance. Any failure, no matter how small, can halt production and cause million-dollar losses. That's why there are huge workshops inside mines, equipped with cranes and tools that look like they came straight out of science fiction. Replacing the engine of one of these trucks, for example, can take days and requires dozens of people. And even with all the costs, all the effort, and all the risks, they remain the best solution. Why? Because nothing else can combine flexibility, efficiency, and capacity the way they do. Trains can carry a lot of ore, but they need fixed tracks. Conveyors can also work, but they cost a fortune to install and can't be moved easily. Trucks, on the other hand, can go wherever needed, follow the excavation front, and quickly adapt to terrain changes. That's exactly why mining trucks are so big, because the modern world needs them that way. If they were smaller, mines would need many more vehicles, much more fuel, and much more time to do the same work. Gigantism, in fact, is the most efficient solution. We've reached the final moment of our journey through the world of mining trucks, these true steel giants that look like something out of a sci-fi movie. Throughout the video, we've seen how they came to be, we've learned about the most impressive models, we've understood the daily life in mines, and the challenges of operating machines so colossal. Now, let's tie all this information together and answer once and for all. Why, after all, are mining trucks so big? The definitive answer to this question is linked to a word that has come up several times here: efficiency. The world we live in depends on enormous quantities of mineral resources. Every day, billions of people use products that contain iron, copper, coal, aluminum, lithium, and many other elements that come from mines. The phone in your hand, the computer in front of you, the electricity reaching your home, all of it is connected in one way or another to mining. And for these resources to reach us, it's necessary to extract and transport absurd volumes of ore. And that's where the giant trucks come in. Imagine if mining companies used regular trucks, the size of the ones we see on highways. The work simply wouldn't be viable. It would take hundreds of trips to move the same load that a single mining truck can carry in just one run. The fuel cost would be enormous, the wear on the vehicles unsustainable, and the operating costs so high it would make many projects unfeasible. In other words, without giant trucks, modern mining would not exist at the level we know today. But it's not just about economics. There's also the need for resilience. These trucks operate in environments that are constantly changing, facing mud, dust, potholes, and slopes that would break any other vehicle in minutes. Gigantism ensures not just load capacity, but also the toughness to survive in such extreme conditions. Another fundamental point is logistics. Unlike trains or conveyors, which require fixed and extremely expensive infrastructure, trucks can move freely around the mine, adapting to daily terrain changes. This flexibility is vital to keeping production constant and ensuring ore reaches its destination as quickly as possible. The future of these giants also promises to be fascinating. We've already talked about autonomous trucks, which are starting to replace drivers in some mines, especially in Australia. This trend is likely to spread, bringing even more efficiency and reducing accident risks. In addition, the push for sustainability is driving the creation of electric and hydrogen-powered trucks, which could completely transform the industry. Just imagine the largest vehicles on the planet operating without emitting pollutants. But even with all this technology, gigantism will remain. Because as long as there is large-scale demand for minerals, we'll need trucks capable of carrying hundreds of tons in a single trip. It's as if these colossi were the invisible link connecting mining to our daily lives. You may never see one of these trucks in person, but you certainly use something every day that only exists because they are out there, working nonstop in mines around the world. Now think about this. Every time you look at a tall building, remember that the steel supporting it came from a mine, probably hauled by a giant truck. Every time you turn on the lights in your home, remember that the copper in the wires had to be transported by one of these machines. Even the electric car revolution, which depends on lithium and other rare minerals, is only possible thanks to the tireless work of these giants of the dirt, rather than the asphalt. In the end, mining trucks aren't just enormous vehicles. They are symbols of what humanity is capable of building when faced with large-scale problems. They represent strength, engineering, and human intelligence applied to a monumental task, literally moving mountains to provide the resources that keep our society running. And maybe that's what impresses most. Not just their physical size, but the impact they have on all our lives. They are invisible to most people, hidden away in distant mines, but they silently sustain the modern world. Without them, there would be no smartphones, computers, cars, trains, airplanes, buildings, electricity, practically nothing we use in our daily lives. That's why, next time you hear about gigantic mining trucks, remember, they're not big by accident. They're big because the world needs them to be. And if you enjoyed this journey into the universe of the largest trucks on the planet, don't forget to subscribe to the channel. That helps us a lot to keep bringing content like this, with stories, curiosities, and explanations about machines, technology, and engineering that make the impossible possible. So click, subscribe, and come along with us, because there's much more ahead.